There we go. So yes, go ahead. Oh, what question did you have? Oh, let me take a look at that. I'm sorry. Let me see here. I need to keep an eye on that. I think that did pass. Here, since we haven't covered if you haven't covered the section, I can extend it, of course. Let me see. Take a look real quick. Here, now, which assignment was that? Because it looks like today a 5.3 and 5.4 due. And then I'm going to be looking at 5.6 and 5.7 and 6.1. 6.1. Let me check 6.1. It does seem to be. Oh wow. Okay, that one slipped through the cracks. I'm sorry. Let me get that one fixed. Let's see here. There it is. Let's see if that's going to make that better. So I've got 6.1 due on the 10th. Okay, so that should fix it. Yeah, sorry about that. I went through the other day and I rescheduled all the assignments. And it looks like that one slipped through the cracks. But it should be good to go right now. It's going to be due on the 10th. There we go. Yeah, thank you for letting me know. Yeah, you should be good to go. That's due on the 10th. And what I'm going to do today, I'm going to go over some problems from 5.6. We went over an outline for how to approach those. Look at some problems from 5.7. We're going to be solving equations using factoring. And then in 6.1, we're getting to this thing called rational functions. Now, the lectures for 5.7 and 5.6, much longer lectures, those are posted. So I'm going to kind of do an overview today. So going back to 5.6, again, the outline. So this is our factoring. So first off, we want to look for a greatest common factor. So if we have a polynomial, we're going to look for the greatest common factor first. Then we're going to consider the number of terms. So first off, if there are two terms. Well, for two terms, what we're going to do is we're going to use those special forms. So you have your a squared minus b squared, a cubed minus b cubed, and a cubed plus b cubed. And these are equal to some formulas or some expressions that we can use to help factor these out. Now, if we have three terms, again, some special forms. So first off, again, let's see here. We could have something that factors into this or factors into this. And then you could also have, oh, I'm sorry, and these are going to be for 3 terms. And again, I'm just sort of rehashing what we looked at last week. So we had the, we need a little more room. I'm just going to have to erase because we're going to need the room. So for 3 terms. So first off, we could have the special terms or the special forms. So let me write these out so you can have a squared plus 2ab plus b squared, which is a plus b squared, and a squared minus 2ab plus b squared is a minus b squared. So you could have that. Or you could have something in this form, say x squared plus bx plus c. And for this, you would use guess and check. So for this one, 2 numbers that add up to b but multiply to c. Finally, for our 3 terms, for this, we would use the AC method. So when we look at the number of terms, if we have 3 terms, we can work with special forms, the guess and check method, or the AC method. And then for part 2 still, 4 or more. We would use factoring by grouping. The last thing we consider with factoring, step 3, is once we've done our first factoring here, there might be more rounds. And in that case, we'll end up repeating steps 1 and 2 again. So let's do some examples. Let's see what this looks like. So let's say we're going to do this. We've got 3x to the 10 plus 3x. So what we're going to think about here is we want to first look at, or step 1, a greatest common factor. So what that means is there's something common to these 2 terms that we can factor out. And what we can factor out is a 3 and an x for both terms. Now, since we're going to be factoring out an x, it doesn't hurt to put a placeholder 1 like that. So now we can factor out 3x. And there we go. So first round, we get this. But now let's take a look at these actual factors. Well, this is a monomial, so there's really nothing else we can do with it. But this is a binomial. In fact, it's a binomial that has something being cubed and something being cubed. What's being cubed? So we can call this step 1. Step 2, well, this is going to be x cubed plus 1 cubed. So what we've got is a binomial, 2 terms. So this would be part A of step 2. And we've got a cubed plus a cubed. So we can use the special form. Let me double check, make sure I got my minus sign. It should be the plus sign first. Yes, it's going to be the plus sign first. Just want to make sure. In this case, A will be x cubed, and B is going to be 1. So what that's going to give us is, we still have our 3x, but A plus B, x cubed plus 1, times x cubed squared plus x cubed times 1 plus 1 squared. And oh, I'm sorry, let me get my minus in here. Minus sign. So we have A plus B, A squared, minus A times B plus B squared. So this will be x to the 6th minus x cubed plus 1. And then bringing this all together, now, what about these two? So we've done step 2. Now we go to step 3. We look at these actual factors. Is there anything more we can do? Well, what we're going to see here, now again, monomial, nothing here. Well, this is actually going to be more cubes. So in this case, we have an x that's being cubed and a 1 that's being cubed. So once again, we can use that special form. In this case, A will be x, B is going to be 1. So plugging this in, so x squared minus A times B, or x times 1, which is x, plus B squared, or 1 squared, which is 1. And we still have this. So putting this all together, So now how do we handle this? Well, this won't factor, but wow, these might. Now this one's kind of tricky. What we can do with this, we can do what's called a U substitution. We can make this observation. So let U equal x cubed. So this will give us U squared minus U plus 1. And if we take a look at this, this is the same thing, or darn close to it, as this. Variable squared minus the variable plus 1. And so what we would do is we would solve for U, try to factor and solve for U. And then once we have a factoring of U, put our x cubed back in for U, replace all the U's with x squared. But this sets us up so we can work with our, we're very familiar with factoring quadratic equations or expressions. So here's the thing, does this factor? Well, we need two numbers that add up to -1, that multiply to 1. I really can't think of a pair of numbers. So there's one way you can check this. Sometimes, as you've seen, polynomials don't factor. We call those prime. One way we can tell this is prime is recall the quadratic formula. I use U here instead. So we can use the quadratic formula. Now in this case, A is 1, B is -1, and C is 1. Now it looks like we got a lot of work ahead of us, but we can take a shortcut. If you've got a quadratic expression like this, or this one here for that matter, if we were to solve for x, we would use the same sort of setup. Let's take a look at what's going on underneath the square root. What can happen is if b squared minus 4ac is negative, that means we're taking the square root of negative. Chapter 7, are we going to be able to do that? So if we get a negative number in here, this isn't going to factor. So we take a look at the square root of b squared minus 4ac. We'll get the square root of -1 squared minus 4 times 1 times 1. And sure enough, this isn't going to work. The square root of 1 minus 4, the square root of 1 minus 4, -3. So what that says is this won't factor because it's also A is 1, B is -1, C is 1. And this, even if we do that U substitution trick, we can't go any farther. So these won't factor. So we're done. This is it. So in your notes, you could say 3x, x plus 1, x squared minus x plus 1, x to the 6 minus x cubed plus 1. That's going to be our answer because the rest won't factor. Questions about that? All right. So just minding the time, let me do a couple more from this section, then I'll move on to 5.7. And again, if you're just joining us, I have a more comprehensive lecture on 5.7 and 6.1 that's been posted. So I'm going to do kind of an overview for those two sections, just so we stay on schedule. let's see here. Let's do this. So let's say we're going to factor this. Now, if we think about the steps that we have, first step is we factor out a greatest common factor. Step 2, we look at the number of terms, and if we have 2 terms, we have some special forms. If we have 3 terms, we can use special forms, the guess and check method, or the AC method. Finally, if you have 4 terms or more, we're going to use grouping. So first off, is there any greatest common factor? No, there's nothing in common to all these terms at the same time. So step 1, there's nothing we're going to factor using GCF. Step 2, we don't have 2 terms, we don't have 3 terms, we do have 4 terms. And so that means we're going to use grouping. So let's do some grouping. So what can we factor out of here? Well, in this first group, there's at least an x that's common. So we have an x. Now, for this group, we have at least a y. So we can at least get a y from each term. So we'll factor out that x. We'll factor out this y. And so now we've got the same thing in both groups. So we'll factor this out, x cubed minus y cubed, x plus y. And so it looks like we've got our answer. Very tempting to say that we do, but we're not quite done yet. Let's go back to these terms, or these factors, I should say. Nothing can really be done with this. But this is a difference of cubes. In this case, A is x and B is y. So what we're going to get is this. A minus B, then A squared plus AB plus B squared. And don't forget we had our x plus y out here. So we've got that. Now, lastly, can we do anything with this? Well, we could treat it as something in terms of x. So we can call this x squared plus yx plus y squared. And we can ask this sort of very tricky question. 2 things that add up to y, but multiply to y squared. 2 things that add up to y, multiply to y squared. Now, what you could do is you could actually use the quadratic formula on this, where A is 1, B is y, and C would be y squared. So if we do that, we solve for x. So negative b plus or minus the square root of b squared minus 4ac divided by 2a. Let's see if this works. Negative y plus or minus y squared minus 4 times a times c. So 4y squared. And finally, we divide by 2a, or 2 times 1, which is just going to be 2. So let me just check my math. Let me make sure I got this right. So there's a, there's c. And we're going to see a problem here. Remember, what's inside the square root has to come out positive. But we're going to get a square root of negative 3y squared. So if we're taking the square root of a negative, it's a no-go. So we don't have to go any further. There's no real factors. Now, no real solution for x. More accurate. Now there's a complex solution, but we'll talk about that in chapter 7. So this didn't work out. So what this means is this won't factor. And that's as far as we can go. So in your notes, this that's going to be your answer. Questions about that? All right. So let's see here. Let me do one more from this section. Let's say we have this. Now let's say we're going to factor this. Now first off, is there a greatest common factor? Nothing in common to these terms that we can factor out. So step 2, well, how many terms do we have? Do we have 2 terms, 3 terms, or do we have 4 or more? We've got 4 or more. So for 4 or more terms, we're going to factor by grouping. So let's see here. Let's say we're going to make this a group. And we can make that a group. So what's in common here? Well, we can at least get an x squared out of here. Now what's in common here? Well, we at least can get a 9. So we can pull out a 9. So let's do that. So that's x squared. We have x minus 4. And we'll have a, I'm going to put a plus here. We're going to have 9. I always put a plus between the groups. If I'm going to put a plus here, I need to remember there's a minus that's going to go on this x. The x needs to keep its minus. Oh, factor out a 9. We're going to have 4. So what do we do here? Well, it looks like we're darn close. X minus 4 minus x plus 4. Well, let me show you a trick. If you factor out a -1 from anything, it switches the signs. So this, if we factor out minus 1, we'll get x minus 4. Now, how do I know that works? Well, work backwards. If you distribute negative 1 to x, negative 1 times x is negative x. And then negative 1 times negative 4, well, negative times negative is positive. You're going to get a positive 4. So if we factor out an additional negative 1, x minus 4 and the x minus 4 are the same. Now I want to show you another way of looking at this negative 1. And in the videos I posted for a 5.7, I think 6.1, I use this other approach. Let me show you what it is. So let's take a look at these factors here. Well, we can get an x squared. But what we can do here, let me start over again. We can take a look at what's common. So again, we can get an x squared. And then here, what we can do is factor out a negative 9. So if you factor out a negative 9 like this, or another way you can see this, you can think this is negative 1 times 9 times x. And this is going to be 6 times 6. Now, you don't have a negative 1 in both places. Now, this one you have x times x squared minus 4 times x squared. And since, yeah, that's going to be fine. Not going to lose the terms there. So this tells you what's common. You can see that x squared, x squared. Now, this one's a little tricky because we can rewrite this as 4 times 9. Now, when we have a negative, we can look ahead. When we factor things out here, we have a positive and a negative. But here they're switched with a negative and positive. So what we can do is we can multiply by 1. Or this will become 4 times 9 times negative 1 times negative 1. And now when you look for things that are common, there's the minus 1, there's the 9, there's the 9, there's the minus 1. So you can factor these two out. So either way, whichever you prefer. But what we're going to get at the end is going to be this. We factor out the x squared. And now we have x minus 4 in both groups. So let's factor out the x minus 4. So we'll have x squared plus minus 9. Or plus and minus is the same as subtraction. You'll have this. So this is going to be a difference of squares, where we have a squared minus b squared a squared, oh sorry, a minus b, a plus b. So just keep this here so we don't forget it. So plugging this in, we'll have still x minus 4. Now here, a is going to be x, and b is going to be 3. So we'll have x minus 3, and x plus 3. And that's it. We've broken it down completely. So any questions about that? All right. I'm going to go on the 5.7. So for 5.7, we're talking about polynomials. We're solving for x is what we're doing. We're going to use factoring. Now, usually x, it could be y or t or something like that. We're going to solve for x, or the variable, using factoring. And what's happening here is what we have what's called the zero product principle. Now, the way it's illustrated in the text works like this. If you have two things, it could be numbers or variables, unknown numbers, or factors, but they multiply together and you get 0. This means either A has to be 0 or B could be 0. So A or B must be 0. So what we're going to use this for is we're going to take some polynomials, we'll factor them, and then use the fact that they're factored to solve for x. And we're going to use this principle. Let me show you. So let's say we have something like this. And let me get a slightly better one than that. Let me go with, let's do this one. Let's do a different one. Let's go with one that's, okay. Let's do this one. So how do we solve for x? Well, what we want to do first is we want to get everything to one side. So if we subtract 2 and subtract 5, oh, add 5x, and what we do to one side, we have to do to the other. So subtract 2, we'll add 5x. Well, these will cancel. You have 3x squared minus 2 plus 5x is equal to 0. Now let's put this in standard form. We have the x squared, and then the x, and then the constant term. So what can we do here? Well, this is an AC method. So we have our A is 3, B is 5, C is -2. So we're going to factor this. Now, factoring for the AC method, A times C is 3 times -2, or -6. So now what we want are two numbers, n1 and n2, where their product is -6. But if you add them together, you're going to get this middle number, hence why I recommend putting it in standard form, equal to 5. So two numbers that multiply to -6, but they add up to 5. So let n1 be 6, and n2 be -1. So what we'll do is we'll rewrite this. As plus 6x minus x minus 2 is equal to 0. And again, 6x minus x will give you that 5x. Now we're going to factor by grouping. So what's in common between these two terms? Well, we can factor a 3. We can factor x. Now what's in common to these two terms? Well, nothing with variables and numbers, but we want to make sure this is positive, so we want to make that positive. We can factor out the negative. So -1. So this is our third step in our AC method. So what we'll get is 3x times x plus 2 plus, and then the -1. And again, I always put a plus there with these. That's going to be all right. X plus 2 is equal to 0. Factor out x plus 2 and x plus 2. This will be 3x plus a -1. That's just -1. And it's equal to 0. Now, what's different from what we did in the past is we have this equal to 0, equal to 0, equal to 0, equal to 0, equal to 0 the whole time. There's an equal sign in this thing. So how does this let us solve for x? Well, that's the extra step that we're going to take in this section. So you have x plus 2, 3x minus 1 is equal to 0. Now we use our zero product principle. This says the product of these two factors is in fact 0. Let's call this A. Let's call that one B. So the thing here is this. When is A going to be equal to 0? Or what value of x will make A 0? So what we do is we take A and set it equal to 0 and solve for x. Now A is x plus 2 in this case. And so we get x is -2. And it kind of makes sense. If you take -2, you put it in here, -2 plus 2 would be 0. And anything times 0 is going to be 0. Now, it doesn't matter what this turns out to be. If you take -2 times 3, you get -6. -6 minus 1 is -7. But 0 times -7 will still be 0. Let's continue on. So now we got to have b equal to 0. So there's b, and then we solve for x. So we're going to get x is equal to 1/3. So same thing. 3 times 1/3 is 1. And then 1 minus 1 is 0. Now 1/3 plus 2, it really doesn't matter. What's that going to be? 7/3. That's going to be 7/3. And yeah, you'll get 7/3, but 7/3 times 0 is still going to be 0. So what happens with these kinds of problems? We're getting 2 answers. Now, usually what they want you to do is put the answers in a set. And so that's going to be it. So any questions about that? We're going to do more of these. I want to show you a peculiar one you want to kind of watch out for. Now, it's oftentimes very tempting to say, well, we can divide x into both of these and again just get x equals 4. But there's a problem with that. There's nothing here that says x couldn't be 0. So that means x could be 0. And if x can be 0, dividing by x will be dividing by 0. So that's going to be a problem. So when you get something like this, let's subtract this onto the same side. Let's make this move first. Now factor out an x. And now we do our a and b. So this will be a, and this will be b. So for a equal to 0, well, that's just x equals 0. We're done. Well, that was easy. Not too bad. Now for b equals 0, x equals. So we're going to get 2 answers in this case. And that's it. Now, let me show you another one here. Let's see, we have this. So again, we've got 3 terms here, but what we could do, let's use that greatest common factor approach. Now again, this is equal to 0. Always want 0 on one side or on the other by itself. Now we're going to factor this, and again, we use our factoring steps from 5.6. Is there a greatest common factor? Well, we could factor 2x from everything. So we've got that. Let me double check my math here. Okay. All right, seems to be okay. But then we can factor this as well. 3 terms, invisible 1 in front of the x squared. That's guess and check method. So 2 numbers that add up to 8, but multiply to 15. Well, that's going to be 3 and 5. So this will become x plus 3 times x plus 5. So putting it all, I'm going to have this. Now, we want to ask this question. We have A, B, and now we have a C. So sometimes you'll get 3 factors. That could mean you're going to get 3 answers. So for A, 2x equals 0. Divide both sides by 2. Get x equals 0. Now for B, x plus 3 equals 0. Subtract 3 from both sides. X is negative 3. Then for C, I'll subtract 5 from each side. And we have x equals negative 5. So we have 3 answers for this one. Oh, we should probably go like this. Negative 5, negative 3, and 0. So any questions about that? So I just want to make a note in here real quick. Let's see. Oh, we're still doing good on time. So let's say you have this. Now we've talked about x-intercepts in the past. To find the x-intercept, we let y equal 0. So what we did with lines to find the x-intercept, we're going to do the same thing with polynomials. And it's going to tell us the same thing. This will tell us crosses the x-axis. So by finding the x-intercept and letting y be 0, we're going to find where this would cross the x-axis. So we make our substitution. 0 equals x squared plus 5x plus 6. And just as before, where we would solve for x, we're going to solve for x here. We're going to solve for x using factoring. and the zero product principle. So that's going to tell us what these x-intercepts actually are. So to do that, again, this is a guess and check, invisible one there. So two numbers that add up to 5 but multiply to 6, well, that's going to be 2 and 3. And then we solve for x the same way. This will be our a, and that will be our b. So x plus 2, 0. Okay. X is negative 2. And then x plus 3 is 0. Subtract 3. We'll get x is negative 3. So what we're going to find is this. Now remember, y is equal to 0 for both of these values of x. So y is still 0. So that means the x-intercepts is going to be 2 of them, not just 1, like with lines. Lines have 1, unless you're a vertical or horizontal line that's sitting right on top of one of the axes. But in this case, we're going to have 2 x-intercepts. 0. And negative 3, 0. Because for both of these, y is equal to 0. And how they usually want you to put the answer in, put it as a set, or negative 3, 0, negative 2, 0. You have a comma separating the points. So that's going to be 5.7. Again, I've got another lecture on this that's posted that has more detail. So I kind of draw out the examples a little more. So if you want a slower presentation, and that's kind of what I prefer, that's available. I posted that video. So let me do 6.1. And 6.1 is where we get into rational functions. So I'll go a little bit over time today. So when we think of rational, think ratio. And so what we're looking at here is a ratio of polynomials. So a rational function will look something like this. Usually it's f of x. You have like x squared plus 2x minus 1. So x cubed plus 6, something like that. This will be a rational function. So rational function is ratio. It's a ratio of polynomials. So the first thing you want to talk about are the domains of rational functions. So the idea of domain is this. It's the allowable functions or values of x. It's the allowable values of x. Now, for what we mean by allowable, so far we've worked with polynomials and lines. Lines are actually a type of polynomial. They're a degree 1 polynomial. And you're free to choose x to be anything you want. And then you do some calculations and you get an output y or an output f of x. But when we're dealing with rational functions, we have to be careful. The polynomial on the bottom, depending on what we choose to be x, could become 0. We don't want the polynomial on the bottom to become 0. Because if we do, we get division by 0, and that we can't have. So we want to avoid those values of x that cause that bottom polynomial to become 0. So for example, something like this. Well, what we want to identify are the values of x that we want to avoid. So even though we're asking about the values of x that are good, let's figure that out by determining the values of x we want to not do anything with. So we want to avoid values of x that cause x squared plus x minus 6 to equal 0. So what we're going to do is, using that zero product principle from last chapter, let's solve for x. Now what we need, this is a visible 1, so it's going to be guess and check method. We need two numbers that add up to x to multiply with -6. Well, that would be 3, -2. And if we think about this, what number plus 3 is 0 will give us 0. That's x is -3. What number minus 2 would give us 0? Well, that would be x equals 2. So these are the two numbers to avoid. So how do we find the domain? Well, we can take all the numbers on the number line except these two. We want to avoid those two. So we can take everything less than 3 off to infinity. We can also take everything bigger than 2 and off to infinity. Now remember, we only have to avoid -3 and 2. The stuff in between is just fine. So we can take what's in between. And so what we're going to get is this. So this is that interval. This is that interval. This is that interval. And that's going to be our answer. Now, as for the top, that's okay if that's 0. That doesn't matter, because you can divide something into 0 as long as you're not dividing 0 into 0. But it's the bottom one we got to watch. So that's how we find the domain. Let's see here. Now, they do talk about the graphs of these things. There's 2 points to mention about the graphs. We're not going to get into graphing these until college algebra. But I do want to make some points. No pun intended. So if you take this function, a very simple rational function, 1 over x, and let's say you do an xy chart or an x f of x chart. And I'm going to pick some numbers seemingly at random. There's a little bit of a pattern here, not totally at random. All we're doing is we're doing 1 over x. So this would be it'd be 1 over negative 10. So we're going to get a fraction of 1 over negative 10. We always draw the negative out. So we get minus 1 over 10. Minus 1 over 5. This will come out to be minus 1. 1 divided by minus 1 is minus 1. 0 is undefined. You have to deal with that. 1 divided by 1 is 1. 1 divided by 5 is 1/5. And 1 divided by 10 is 1/10. So I'm going to do a very loose graph. If we were to graph these, there's 1, 2, minus 1, minus 2. Here's negative 10, negative 5, negative 1, 1, 5, 10. So I'm playing with my window here. I've got my y-axis stretched out and my x-axis compressed in. But we're going to still get roughly the same shape. So negative 10 and negative 1/10 is right about here. Negative 1/5 is about there. Oh, negative. Oh, I'm sorry. I need to be negative, so I need it down here. So right here. And this here. And then over here, we'll have 1 and 1. 1/10 here, and this here. So what we're going to get is something that's doing this. Now, what's going to happen as we get closer to 0? 0 is undefined. And so what you're going to find out in college algebra is when you have a division by 0, if a value of x causes a division by 0, you're going to get what's called a vertical asymptote. This is a barrier that the graph cannot cross. So the graph will still exist for these other values. It'll get close and close to the y-axis, but won't quite cross it. It's going to get really close to the y-axis again, but it's actually not going to cross it. It'll just keep dropping down. And it's actually never going to cross the x-axis either. It just kind of goes on like this. So it's forever in this third quadrant, forever in that first quadrant. Now, That's usually what happens. Now, we're not going to be doing much with this kind of thing in this class. But I do want to show you something we will be working with. Let's say we have this. Now, let's say we're going to graph this. One thing we can do, we want to be careful. We talk about the domain of a rational function. We want to talk about the domain before we do any reducing. We're going to talk about reducing in a second. But we've seen that we can factor x squared plus 5x plus 6 into this. And what we can do is we can cancel the x plus 2's. And we're going to get x plus 3. So when we graph this, this simplifies into a line x plus 3. The key phrase it'll look like, but it won't be exactly y equals x plus 3. The reason is this. The domain of this function, we find the domain before we simplify. So we want to determine the domain before we simplify. And what we're going to find is this. The domain cannot include -2 because -2 plus 2 is going to be 0. So again, we set the box, solve for x. And so we find out we want to avoid x equals -2. X equals -2 is not in the domain. So this is what we're going to get. Let's graph this thing. Let me see how we're looking on time. Okay, so I'm going to go over a bit in this part because we're covering basically almost 3 sections. But again, I have the detailed lectures posted if you want a slower presentation. Now, if we graph this line, we're going to get something like this. Oh, I want to miss my intercept. But what's going to happen, so this is what y equals x plus 3 is. But because this is f of x equals x squared plus 5x plus 6 over x plus 2, we can't let x be -2. So at -2, there's a hole in our graph. So that's the difference. The difference between y equals x plus 3 and f of x is is going to be that whole. So I mentioned simplifying. So what's left for, I'm just going to do about 3 more examples, and that's it for this section. So I want to talk about simplifying real quick here. Well, not real quick. I want to make sure we go over this. And again, there's a more sort of more examples version of this lecture. So for 6.1 here, simplifying, basically we're reducing rational functions. So what we're going to do, we're going to reduce rational functions just like we're reducing fractions. So if you have 6/8, you can call this 2 times 3. This would be 2 times 2 times 2. Cancel some 2's. And we're left with 3/4. So what we're going to do with rational functions, we'll take the 2 polynomials, the one on top and the one on bottom. We'll break them down into factors. So once again, we're going to factor both of these polynomials now. And then what that's going to do is it'll let us cancel things. So let's see here. Let's say we have this. So what we want to do is we want to factor the 2 polynomials. So for this one and this one, they have that invisible 1 in front. So what we'll say is guess and check and guess and check. 2 numbers that add up to 7 but multiply to -18. That's going to be x plus 9, x minus 2. 2 numbers that add up to -3 and multiply to 2. X minus 1, x minus 2 again. And now we look for common factors. Common to the top, common to the bottom, and we have a pair of them. X minus 2. So again, x plus 9 over x minus 7. I'm sorry, x minus 1. And that's it. So what you're going to do with these is you'll factor the numerator and denominator. And then once you get everything factored, look for factors you can cancel, and there you go. Now, this is a packed section. They put in a lot of stuff here. So let me show you the next thing they want you to do, and it's multiply. So a key theme that you're going to see here for this section and the next section is we're going to treat rational functions, the next 2 sections actually, we're going to treat rational functions like they're fractions. So it's like with fractions. So remember, you multiply fractions, you take 2/3, say times 1/7, You multiply across. 2 times 1, 3 times 7, 32 over 21. Same thing with rational functions. We're just going to multiply across. Now, there's a pro tip here. Is when we multiply across, before we combine things, look for factors that'll cancel. So let's say we have this. Let's see, we get a good one here. Make sure I got this copied down correctly. Okay, it's good. So let's factor things. And what we're going to do, we're going to be factoring these and these. Now this one, we can rewrite this one if we want. Is say 2yx. And the same thing here. We call this 2yx. And treat y like it's a constant number. So we can ask this question. The sum of what? What two things can we add up to get 2y if those two things multiply to y squared? Well, y and itself. Y plus y gives you 2y. Y times y gives you y squared. Put my minus here. Now, same thing. Two things that add up to negative 2y, but multiply to y squared. It turns out it's going to be negative y with itself. Negative y plus negative y is negative 2y. Negative y times negative y is y squared. So this means x minus y, x minus y. Now what do we do here? Well, we can factor out a 4. And on the bottom, we can factor out a 3. So now we multiply things together. And there we go. Now, before we start trying to like FOIL things and combine them, and I believe in the text, they're okay with leaving you, you don't have to FOIL things together. You can leave it as a product of factors, which really helps. Let's look for cancellations. Well, we cancel this, and we can cancel that. So what do we have left? Well, bring out the 4 in front. I'm not going to distribute it. I'm just going to leave it in front. And then the 3, like that. And that's going to be your answer. So the actual multiplication part is just kind of shoving them together, really. But what you want to do before you do that, factor things out. Once they're factored, shove them together, and before you combine anything, look for cancellation. So division, do an example with division. And I just want to show you one quick example after this, just to make sure you're comfortable plugging in values of x, and then we're done. That'll be it for this section. Again, there's a more example-based version of this lecture that's been posted. So again, it's like fractions. So if we take 2/3 and we divide by 1/7, we can do our KFC. Keep, flip, change. So we'll keep the 2/3. We'll flip the 1/7. We'll change this to multiplication. And now we just multiply across. We get 14/3. So with rational functions, we're going to do exactly the same thing. So let's say we have this. Let me do a different one. So I think this one, that one was in the other lecture. So I want to give you a collection of examples to work with. There's a plus and a minus 21. I don't think so. I think it's minus 28. Ooh. Let me check this real quick. Then we divide by this. So we're going to do the same thing. We'll keep the first rational function. We'll flip the second. We'll change this to multiplication. So we keep this one. Flip this one. And then we're going to multiply. And again, we want to factor these polynomials. So what we can do, two numbers that add up to 4, multiply the negative 21. Will be 7 and negative 30. Two numbers that net add up to 3 and multiply the negative 28. Will be again 7 and negative 4. Now, two numbers that add up to 4 and multiply the negative 32, 8, negative 4. And then this one, two numbers that add up, that multiply, add up to 14 and multiply to 48, 6, 8. So before we multiply things, we can do some cancellations. We can cancel this, and we can cancel that. And now we multiply things together. And that basically means we just put them together. And again, we can cancel y minus 4, y minus 4. So the final answer, y minus 3, y plus 6. So any questions about that? So let me do one real quick example. This is something that, mentioned in the beginning of the section. Just want to make sure we're all okay with it. But let's say we have f of x equals x cubed plus 1 over x squared plus 6x plus 8, something like this. And let's say we're asked to find f of 2. So just to make sure we're okay with this is that function format, or that function notation. So what this says is replace all x's with the number 2. So what that's going to mean, f of 2 will be 2 cubed plus 1 over 2 squared plus 6 times 2 plus 8. And again, we can follow our PEMDAS. Exponents will be first. This will be 8 plus 1. Exponent would be 4. And then this would be 12, and this would be 8. So this will be 9. And then 4 plus 12 is 16 plus 8 is 24. And that's going to be our answer. So just wanted to cover one of those examples, just if any questions about those, I'm just going to replace the x's, in this case with the 2, or whatever number they're giving us. So that's it. That's basically 5-6, 5-7, and 6-1. Now again, 5-6, there isn't a slower lecture for that one. But for 5-7 and 5-6, there are. We break it down more. So there's slower examples, more step-by-step, more sort of those tricky questions, factoring out the -1 and getting the signs to switch. This can always work if you have a plus b. It's always equal to -1 minus a minus b. Or if you have a minus b, this is -1 times -a plus b. And or you could have -a plus b. That would be -1. And it's going to be a minus b. Let's see if there's any ones in this. Or if you have negative and negative. -a, -b, -1, a plus b. Factoring out a negative switches the signs. If you factor out a -1, you'll switch the sign. So that's it. Let me know if you have any questions. Again, 6.1, I've moved that. It's now due on the 10th. And we'll probably do a review. Let's see, we have, oh no, we're not quite there yet. We've done the test for chapter 3 and 4. And then we'll lecture on. We'll be looking at 6.2 and 6.3, maybe a little of 6.4 on Thursday. I'm going to post those lectures, give different versions of those that are section by section, if that's going too fast. Again, I'm just trying to keep us on schedule. So there'll be longer versions of those lectures if that's going to help. So other than that, have a wonderful day, and let me know if you have any questions.
Is exam 2 due today?
It should be. Exam 2 should be due today.
Okay.